Okay, so now, sorry guys, I'm just trying to get the screen in here. Okay, so let's look at screen 3, problem 3. So you're asked, tell how many triangles RST are possible, rounding answers to the nearest tenth. So right now, I know there's a lot of stuff up here. What I would tell you to do is to just stay with me. It's a long problem. All right. So first thing I do is I'm just going to draw a triangle, putting in all the information that I'm given. So I'm given that angle S is 126 degrees, side S is 12, side T is 7. Now based on the law of sines, since I have angle S and side S and side T, I should easily be able to get angle T. So that is what I'm going to do. So I set my equation up, my proportion to be side T over sine of angle T is equal to side S over sine of angle S. So if you follow with my proportion and I fill in the information and then I cross multiply and divide, you're going to notice I end up with 12 sine T is equal to 7 times sine of 126 degrees. So when I did that and I divided by 12, notice that I'm looking for the sine of T. So I'm looking for an angle. And remember that whenever we do angles, we have to press the second arc sine button. So when I do arc sine of this entire thing, I'm going to end up getting 28 degrees. So now, here's the most important part of the problem. This is the analysis. So I want you to analyze the angle, right? So since the value of sine is positive, the angle could be in quadrant 1 or quadrant 2, because in quadrant 1 and quadrant 2 is where sine is positive. So I look and I say to myself, well, quadrant 1, 28.2, in quadrant 2, subtract from 180 gives me 151.8 degrees. So that would be one of two triangles that may be possible, right? It may be that I have a triangle with angle T as 28.2 degrees, or I may have another triangle along with this one where angle T is now 151.8 degrees. So I look back and I see easily enough that I can't have 151.8 for angle T. Otherwise, that's already bigger than 180. So what do? Well, I have to reject 158.1 degrees since we were told that angle S equals 126, and I know that a triangle can't have two obtuse angles. So only one triangle is possible with angle S equals to 126, angle T is 28.2, and then angle R, which I subtract from 180, gives me that 25.8 degrees. So for this problem, only one triangle is possible. So if you need to pause or stop or bring any of this up so you can get the work that you missed, please feel free to do so. The next problem is, which is kind of similar, is going to be this one. So in this one, and again, let me try to minimize a little bit because it can get a little bit overwhelming. So it says, tell how many triangles are possible, rounding answers to the nearest tenth, and to state the angle measures. So again, draw a triangle. It doesn't have to be to scale, but again, I say that because it always helps to have a visual. So I'm given in my triangle ABC, the angle C is 25 degrees, side C is 2 units, side B is 3 units. So hopefully by now you see that with what I'm given, the easiest thing to find would be angle B. So when I set up my proportion, that's what I did. I have side B over sine of angle B equals to side C over sine of 25 degrees. So I plug my numbers in, I work it through, and again, there are lots of things here. I would say don't worry about the left-hand side in the green. We'll explain that in a little bit, but I just want to state here to find out what angle B could be. So when I cross multiply, I have sine B is equal to 3 times sine 25 degrees divided by 2. Again, I'm looking for the angle, so you are going to need to use that sign with the -1, the arc sign, to find your angle, okay? So once you do that, I'm hoping this is what you got. I'm hoping that you, on your calculator, got 39.3 degrees. So now, let's analyze this. In quadrant 1, angle B is 39.3. But because sine is positive, I could also be in quadrant 2. And in quadrant 2, angle B is 140.7 degrees because I subtract from 180. So my question is, are both of these triangles possible? In the other problem, number 3, the answer was no, because 2 of the angles happen to be obtuse. Well, here, if B is 39.3, and it's given that C is 25 degrees, I can subtract from 180 and find the angle A is 115.7. So that's possible, right? At up to 180, not a problem. And now look at triangle 2. In triangle 2, quadrant 2, angle B would be 140.7 degrees. Again, angle C is given to me as 25 degrees. When I add the two of them up, I get 14.3 degrees, which works because, again, all three adds up to 180. So in this particular case, two triangles are possible. One with these measurements for A, B, and C, and the second triangle with these measurements for A, B, and C. So these are the model problems or the worked out problems for the law of sines. So look it over. I'm hoping that the explanation helps you. And as you do, well, let's look at slide 4 together. So whenever you're done with this, go ahead and go back to and go on to slide 4 with me.